Hello everyone, welcome back to my channel InfoSec Lab. Today we are going to talk about enumeration and proof-of-work in web app pen testing. Specifically, we're going to focus on the authentication process on web applications. Your learning objective of this video is to understand the significance of enumeration and how it sets stage for effective proof-of-work attack. You also learn about advanced enumeration methods, mainly focusing on extracting information from verbose error messages. You also learn about comprehend the relationship between enumeration and proof-of-work attacks in compromising authentication mechanism. And last but not least, you're going to work on a few hands-on exercises about authentication enumeration. Before starting this rule, you should have a basic understanding of HTTP and HTTPS, a request response with their status codes, as well as some familiarity with the tools like Verbose and Linux command line. So what is authentication enumeration? Basically, it's a process where attackers try to find out as much information about the authentication process of a web application. Their ultimate goal is to identify valid username or email address on the system and try to retrieve the password policies. With those retrieved information, they can actually grab the payload to brute force against the users on the system. So knowing about the username, let attacker focus on the password. It can figure out the usernames in a different ways, like observing how the application responds during login or password resets. Password policy is the guidelines when creating password can provide valuable insight into the complexity of the password used in the application. By understanding these policies, an attacker can gauge the potential complexity of passwords and tailor their strategy accordingly. So I'm not sure what happened to my browsers that result in this step. It's kind of hard to read, but basically this is a code in the backend how the application is implemented. When it comes to identifying valid username or email addresses, there are several places on the web application so that we can take a look at. The first thing is registration pages. Usually when you go sign up for an account, you'll be asked to prompt to input username or email address, and they have to be unique. If you, by chance, input a username or email address that has been used in the system, then you're going to be given an error saying, well, the email or username has been taken. If you take a look at the sample, let me see. For example, on this website, we can try to join for free, create a new account. And I'm going to use my username, which is already on the system. You see, the username is taken. This is where you figure out that that username is valid or not. The same concept to apply for the email address. If you input an email address that's already in the system, you're going to get a similar error message that email is taken. Try another one. Okay. Also, on this registration page, you'll be able to find out the password policy. How? Remember when I was trying the weak password? Please make it stronger. You can use uppercase and lowercase characters. Use a symbol, right? So I can just try doing it and then strong password. And it allows me to sign up once all the information is validated. Now, depending on the applications that your error messages may be different. A lot of times I've seen applications where they just say, oh, your password does not meet the requirement. In this example, TryHackMe's has done a very good job at making the error message as general as possible. We don't know the exact password policy. We only know that you can try upper and lowercase characters or a symbol. It doesn't specify the password policies. Whereas a lot of web applications, they say, your password doesn't meet the requirement. Please include at least one characters, one number, one uppercase, lowercase, etc. So that's how you find out the password policies. The second place where you can find out valid username or email address is the login page. Well, similar with the sign up page, when you try to input a username or password in the system, now you see here there's an error saying, oh, your email or password is incorrect. So in this case, attackers don't know whether the email is incorrect or the password is incorrect. It can be both or either. For an insecure web application, the error message would be specifically addressing the wrong input field. For example, on some web application, they will put like, your email is incorrect or invalid email address or invalid username. That's how we figure out. So that username that we try is not in the system. Whereas if you input a username that's in the system already, then you're going to see a different error message saying, incorrect password or invalid passwords. That's how we identify valid usernames or email addresses. The third place to look for that is the forgot password, reset password function. Well, the concept is similar. When you try to input email address or anything else, let me try. So when I try to reset a password, now TryHackMe will provide a message. If your account exists, you will receive an email, meaning that in this case, attackers cannot know whether the email exists in the system or not. Whereas a lot of applications, they will give you an error saying like the email is not in the system or try again, or something else like if the email is valid, then it will say an email has been sent to your email address. Please check your inbox for the instructions or something else like that. That's how you identify whether the email address is in the system or not. Cool. So we cover common places, the registration pages, password reset function, verbose errors. Those errors are popping up when we try different inputs on the applications. Data breach information. This is very important. If you pay attention to the breach data on the internet, you'll be able to see sets of credentials used by user. A lot of times, internet users tend to reuse their credentials on different web applications. If by chance you find a set of credentials of a user from one website, you can actually try that credential on another website. Who knows? Chances are that user are using the same set of credentials. All right, so answer the questions. What type of error messages can intentionally provide attackers with confirmations of valid username? Verbose errors, enumerating users by verbose errors. Okay, understanding verbose errors. Imagine you are a detective with a lack of spotted clues that others might overlook. In the world of web development, verbose errors are like an intentional whisper of a system, revealing secret meant to be kept hidden. These detailed error messages are invaluable during the debugging process, helping developers understand exactly what went wrong. However, just like an overheard conversation might reveal too much, these verbose errors can unintentionally expose sensitive data to those who know how to listen. Verbose errors can turn into a goldmine of information, providing insights such as internal paths, like a map leading to hidden treasure. This reveals the file path and directory structures of the application server, which might contain configuration files or secret keys that aren't visible to normal users. Database details. Offering a sneak peek into the database, these errors might spill secrets like table names or column names details or the database that the application is using. Users' information. Sometimes these errors can even hint at usernames or other personal data, providing clues that are crucial for further investigation. So what can we deduce from the verbose errors? Attackers use verbose error as a way to force the application to reveal its secrets. Below are some common techniques used to provoke these errors. Invalid login attempts. This is what we talked about earlier. That we try to input different usernames or email addresses and see how the application responds, what error messages are displayed on the applications. And from there, we can try to grab our payload or we can try other usernames or email addresses. SQL injection. This technique involves slipping malicious SQL command into entry fields, hoping the system will stumble and reveal information about its database structure. For example, placing a single quote or quotation mark in a login field might cause a database to throw an error, inadvertently exposing details of its schemas. This is something that I haven't mentioned, but when you try to input invalid username or password, if the application is not secure, then it might provide you information about the database that the application is using. This is important because if we know what database is used, we know the syntax, and the only thing we have to worry about is the table's name, the database name, and the column's name. File inclusion and path traversal. By manipulating the file paths, attacker can attempt to access restricted files, causing the system into errors that reveal internal paths. For example, using directory traversal sequences like ... could lead to errors that disclose restricted file paths. Form manipulation. Tweaking forms field or parameters can trick the application into displaying errors that disclose backend logic or sensitive information. For example, altering hidden form fields to trigger validation errors might reveal insights into the expected data format or structure. Application fuzzing. Sending unexpected puts to various parts of the application to see how it reacts can help identify weak points. For example, tools like Verbose intruder are used to automate the process, bombarding the application with varied payloads to see which one provoke informative errors. So what are the roles of enumeration and proof forcing? User enumeration is used to discover valid usernames that set stage, reducing the guesswork in subsequent proof force attack. Think of that. In the real scenario, we can't just blindly proof force user credentials because there are millions of email addresses and there are an infinite amount of possible username. We can't just blindly proof force that. And then with that infinite amount of username plus the infinite amount of passwords, it is almost impossible to perform a proof force attack on the users unless we get some insightful information about the system or the username. Then it's become easier for us to perform the proof force attack. Exploiting verbose errors. The insights gained from this error can illuminate aspects like password policies and account locked-out mechanisms, paving the way for more effective proof force strategies. Alright, so in summary, verbose errors are like breadcrumbs leading attackers deeper into the system, providing them with the insights needed to tailor their strategies and potentially compromise security in ways that could go undetected until it's too late. Alright, let's go to the first lab of this room. Enumeration in authentication forms. In this HackerOne report, the attacker was able to enumerate users using the website's forget password function. Similarly, we can enumerate emails in the login forms. Alright, so let's go to this page. Let's try some random username. Okay, so we have email does not exist. Alright, however, if we email already registered, the website will respond with invalid password error message, indicating that email exists in the database, but the password is incorrect. So we can try test at test. Alright, invalid password. So we have two different error messages for invalid input fields. If we get the invalid password, meaning that the email address field is correct, this email exists in the system. If we get something else, like invalid email does not exist, meaning that the email that we just tried is not in the system. So it's skip it. Automation. Okay, I don't know what's going on, but I'm gonna copy the code here and create that in my terminal. We'll need a list of common username, which can be downloaded here in this repository. Oh, before I run the command, let's go over the script and see what it does. So basically, what it does is, this is going to be the URL of this web application. This is where we're going to perform the brute force attack. And this is the headers of the request that we put in. Everything is predefined for us, so we don't have to worry about this. And this is the data that is included in the post request body. So in order to figure out what the post data is, you can actually try to inspect the browsers. Go to the network tab right here. And then every time I try to submit, you're going to see a post request right here, and then click the request tab right here. You're going to see the form data. Usually on most web applications, you only have the username and password. In this specific application, it also has another field called functions. And if you notice, the URL is different too. In TryHackMe's labs, Verbose login functions.php, whereas over here. So it's sending the post request to a different URL, which we can confirm right here. The functions. All right, with data, this is making requests and then investigate, putting the response into a JSON format. Over here, we have enumerate emails. These functions basically, let's see. This function basically opens the email list and look through each of the emails in the list and try to input into the email field right here to see whether we have this email does not exist error or the incorrect password error. If we get the incorrect password error, it means that that specific email is in the system. So we are, or in other or in other words, we are able to identify a valid username, email address. All right, so let's run it. We'll let it run for a little bit, and it should give us the email address. Now, if you remember, I mentioned earlier that sometimes we have to reach out to the internet to see the rich data, right? This is where you find the rich data. When you surf online on Google or on GitHub repositories, there will be a lot of places where you can retrieve rich usernames or the most commonly used username or email addresses. Another one that I would recommend you take a look at is Setlist. Now, this is a very, very common list of all username password that provides, well, basically it provides, it's like a dictionary of the payloads where for your brute force attacks and application fuzzings, it provides all the details on AI, LLM testing, this fuzzing, password cracking, username cracking, web shells, and etc. So this is a very, very useful list that you should bookmark for yourself. All right, let's go back. And we found a valid email address, Kennison@gmail.com. All right, moving on next. Exploring vulnerable password reset routing. The password reset flow of vulnerabilities. Password reset mechanism is an important part of user convenience in modern web applications. However, their implementation requires careful security considerations because poorly secure password reset processes can easily be exploited. Email-based reset. When the user resets the password, the application sends an email containing a reset link or a token to the user's registered email address. The user then clicks on this email, which directs them to a page where they can enter a new password or confirm it, or a system will automatically generate a new password for the user. This method relies heavily on the security of the user's email account and the secrecy of the link or the token sent. Security. Now, if the user email is compromised, then of course attackers can easily get access to the instruction links or the token sent to that email. Security-based question. This involves the user answering a series of pre-configured security questions they have set up when creating the account. If the answers are correct, the system allows the user to proceed with resetting the password. While this method sets a layer of security by requiring information only the user should know, it can be compromised if attackers gain access to personal identifiable information or PII, which can sometimes be easily found or guessed. Again, this is not a very big fan of security question-based reset because a lot of web applications, they use so common questions like, what's your maiden name? Now, if you've done OSINT or reconnaissance on a person, obviously it's not very hard for you to find out that person's maiden name. Similarly, it's not very hard for you to find out where that person, which high school that person went to, or if that person has a pet and what his or her pet name is. And basically, those are some of the security-based questions that are asked on a lot of web applications. Also, some questions can be some questions whose answers can also be brute forced, like what's your favorite colors? Think about that. Like there are only several colors like red, blue, green, pink, orange, yellow. Only a few options which can be easily brute forced. So that's why I'm not a very big fan of security questions. If you ever try to have a setup, try to think of something that's not only personal to you, but also in a creative way that nobody can guess. All right. SMS-based reset. This function similar to email-based reset, but uses SMS to deliver a reset code only directly to the user's mobile phone. Once the user receives the code, they can interact on the provided web page or to access the password reset functionality. This method assumes that access to the user phone is secure. but it can be vulnerable to SIM swapping attacks or intercepts. So it means that, attackers can actually swap the SIMs of the user's phone number and then took over the phone number, and hence attackers can get the reset token. Each of these methods has its own vulnerabilities. Predictable token. If the reset token used in the links or SMS messages are predictable or follow a sequential pattern, attackers might guess it or brute force their way to generate by reset URLs. Token expiration issue. Tokens that remain valid for too long or do not expire immediately after being used provided after use provide a window of opportunity for attackers. It's crucial that tokens expire swiftly to limit this window. Insufficient validation. The mechanisms for verifying a user's identity, like security questions or email-based authentication, might be weak and susceptible to exploitation if the questions are too common or the email account is compromised. Again, we talk about that. Some security questions are so common that it can be easy to guess, especially if you do reconnaissance on the person. Information disclosure. Any error message that specifies whether an email address or username is registered can inadvertently help attackers in the enumeration process. Confirming the existence of accounts. Insecure transport. The transmissions of reset links or token over non-HTTPS destination can expose the critical elements to interception by network eavesdroppers. Alright, let's move on to the second lab. Enumerate or brute forcing the unpredictable tokens. So here's the URL for the second lab. And then navigate the application's password set and then input admin.com. Let's see. Forgot password, admin.com. You see a password reset link has been sent to your email. So let's try some other random email address. And no accounts found with that email. Again, verbose error messages are very important because it gives us information about the system. In this case, as you can see, I tried some random email address and it shows that no account was found with that email. Whereas when you try the admin.com, it says a password reset link has been sent to your email. This is how we identify a valid email address. Okay. The application will respond with a success message. Alright, we talk about for demonstration purposes, the application uses the reset link. Okay, which includes the token. We have invalid token. So our job right now as an attacker is to brute force a token. Now since it's only 3 digits, it should be a piece of cake for Verbose to do it. Let's try it. Now keep in mind that in modern web applications, the minimum or the most used token are 6 digits or more. But in this case, because of the demonstration, it's only 3 digits. Right. So first we gonna need the step traffic. Go proxy, switch on, Verbose, and then now we're going to send this one. No, that is one. It's one. Send this one to the Verbose intruder, where we set payload for the brute force. Going to select this one, add, and over here in the payload, we're going to use a sample list. Now there are 2 ways to do it. We can use a simple list where we load the OTP, not text right here. The OTP.txt is just a list of the token that I generated from 100. No. From 100 to 200. Right here. So you can actually choose it and put it right here. It will automatically load on the payloads. Or you can just try numbers and from 100 to 200. Step is 1. And maximum integer is 3. Minimum integer digits is 3. Maximum is 3. Now in a real world scenario, you may have the token like 0561 or something. So it might has less than 1 digit compared to any other tokens. Because of that, in real life, when you set the when you configure the payload, you have to make sure that the minimum integer is 6 digits or more, depending on the token. Make sure that the minimum integer is always the number of the length of the tokens. So otherwise, I won't work, or you may have missed it. So from 100 to 200, minimum integers, okay, everything is set. One more thing, now we have the invalid tokens right here. We're going to filter that. Going to this one, in the settings, grab match. First, we clear all the payloads on the error messages and then input this one. So basically what it does is in the output of the brute force attack, there's going to be a column says invalid token. And if the value is 1, meaning that that response contains this specific error message, meaning that the code that we just tried is invalid code. If we successfully crack the OTP, then we won't be able to see this invalid token in that response. All right, let's try. You see over here, because these codes are invalid, we always see invalid token with the value of 1, meaning that in these responses, it contains the error message invalid token. My bad. Okay, so now the only thing we have to look for is the request who response doesn't have this error message. We'll get that sometime. So in the response, it will say your new password is something, and we're going to use that to log in with the admin. TryHackMe also provided a command to generate the payload, and this is the command that they use. Basically, the crunch command create with the minimum length of 3 and maximum length of 3. I'll put all the data into the otp.txt file, and then this is going to be the format. Because the token is 3 digits long, then it's going to be 1, 2, 3 places. And then starting from 100, adding 200, which is the range of the payloads. Okay, we still haven't got anything. That is super weird. Simply, the attack will take some time to finish using buffs with. However, once successful, you get a response with a much bigger content compared to the responses with invalid token error message. So this is another way where we can identify the valid code by looking at the length of the contents. But that's not always the case, because a lot of times you may get different length for different responses, and it's almost impossible to determine whether we were successful or not based on the content length. Here, I guess we do have it. You see, right here, the content length is different. We have 1127, we have 1067, 68. So these are similar, so we can guess that these are invalid. Whereas this one, 1127, right here, 179, meaning this is the correct one. You see here, under the invalid token, there's no number 1, meaning that this request has a response that doesn't contain the invalid token in the response. Right. And we should see a new password right here. And now we can actually log in. Admin.com. And we got a flag. Yay. Exploiting HTTP basic authentication. Basic authentication in 2024. Basic authentication offers a more straightforward method when securing access to devices. It requires only a username and password, making it easy to implement and manage on devices with limited processing capabilities. Network devices such as routers typically utilize basic authentication to control access to their administrative interface. In this scenario, the primary goal is to prevent unauthorized access with minimal access setup. While basic authentication does not offer robust security features provided by more complex schemes like OAuth or token-based authentication. Its simplicity makes it suitable for environments where session management and user tracking are not required or managed differently. For example, in devices like routers that are primarily accessed for configuration rather than regular use, the overhead of maintaining session states is unnecessary and could complicate the device performance. HTTP basic authentication is defined in RFC 7617. So if you're interested, you can take a look at this one. This is the URL. So I haven't read it, but I believe this is going to be a brief introduction of the basic authentications. All right, so HTTP basic authentication is defined in RFC 7617, which specifies that credentials, username, and password should be transported as the basis for encoded string within the HTTP authorization header. This method is straightforward, but not secure over a non-HTTPS connections, as base64 is not an encryption method and can be easily decoded. The real threat often comes for weak credentials that can be brute forced. HTTP basic authentication provides a simple challenge response mechanism for requested and user credentials. Right. So we perform a GET request. We're going to get a 401 unauthorized. Over here, we'll be prompted to enter the credentials. We send the credentials back to the server. Once it's checked, it will return a 200 if the credentials are valid. Otherwise, we get a 401 unauthorized. So let's take a look at this one. We try to access this website, this URL. As you can see, I try to perform a GET request to this URL, and then I'm prompted to enter user credentials. I want to try admin and password. Sign in. Over here in Verb, I do get a GET request. I can actually try to see what it is by sending it to repeater. Right. So remember we read about this earlier. The credential is in the authorization header right here, and the basis for encoded. In Burp, it automatically decoded for you, so you don't have to do it. So you can see admin password. Now, what we're going to do is to brute force the password for this admin user. Right click on send to intruder. Over here, we're going to select this payload right here, the encode basis for encoded. Over here to the payloads, we're going to load the password list. In this case, I'm going to use a 500 words password text. Scrolling down to the payload processing section. If you remember, the format is username, column, and password. So what we're going to do is to add a prefix to each of the password we try to brute force here. Right, add a prefix, which is going to be admin column. Then after that, we're going to base64 encode the whole thing right here. All right, so we're going to add another rule, encode, and base64 encoded. And we start the attack. As you can see, most of the responses are 401 unauthorized, meaning that the set of credentials we try are invalid. We're going to look for the status code 200. Okay, it's going to take a while, so let's go back to the room and see what else we have. So these are just like instructions, okay. What is a flag? Okay, so we're going to log in and get a flag. Try using Hydra instead of Bub to brute force the password. Okay, we can try that. I haven't used Hydra for a while. Not sure. So for those of you who don't know, Hydra is a powerful tool used for password cracking, hash crackings, and some other functionalities that I don't want on multiple services. It's not only for HTTP, it's also for SSH, FTP, SMB. So it's a very powerful tool. Also, because of that, it's a little bit complex and a little bit hard to use. So if you're not familiar with that, don't be discouraged. All right, so Hydra. So the lower L is for a single user, and then the capital P is going to be the password list. Here is the service name, which is set to B. We are going to use the HTTP, and this is the IP address. All right, let's try it. Hydra.l admin.p 500 password. And we are going to perform a HTTP GET request. So it's going to look like that. And we're just going to copy to the URL, which is enum basic. Enum basic labs basic authentic. Okay. Let's try it. Oh, look at that. The password is yellow. We got it. How about web suite? Have we found it? No, we haven't found it. So Hydra is much faster. No. Don't get it wrong, because we are using the Burp Suite community, which is a little bit slow. If you upgrade that to Burp Suite Professional, then it's going to be super fast. I mean, obviously, you will have to pay a ton of money, which you don't want to do it. So when it comes to password cracking or hash cracking, you have multiple options. You can use Burp Suite, you can use Hydra, you can also use FFurf and some other tools available on the terminals, depending on your comfort zone and your familiarity with the tools. It doesn't really matter. All right, so I'm just gonna turn up this one first and try to log in with the credentials. Green, yellow, and we got a flag. All right, let's just wait for Burp to finish the tag. Oh, there it is. Now, it would take a look at the response right here. Let's double check right here. Copy this one, and I'm going to cyber shape. It should be admin yellow. Once we decode it. Over here, you can take a look at the response too, which is TryHackMe's basic off. Okay, from cyber share. There we go. We have the admin yellow. This is what we're looking for. This is what it's supposed to be. So basic authentication is easy to crack. It's easy, it's insecure, but it's convenient for devices that requires minimal setup. Now, how do we prevent this? We'll maybe just use a complex password that's not in the password list. So it's going to be a little bit harder for attackers to brute force it. Well, I'm not saying it's not impossible. It's just like make it harder for attackers. So yeah, that's why we have to use a strong password as long as possible, like at least minimum 8 characters, uppercase, lowercase, a number, and then special characters. By doing that, let's try that. By doing that, we can actually have a long base 64 encoded string, which is hard to crack. Let's try that. I mean, 2 base 64 right here, yellow. Let's try hello, stop infos. 1, 2, 3, 4, 5. You see, the string is long, and then it is almost impossible unless the attacker somehow get to my password. It's almost impossible to crack this one. OSINT. So what's OSINT? OSINT is open source intelligence, which is a technique used by penetration tester and attackers to find information about a company or a web applications. There are several tools to do it: Showdance, Google Docking, GitHub, Webalizer, several tools, and then we also have the Wayback URLs. So Wayback URLs is a website where it contains all the versions of a specific web application. So if you go here and you type facebook.com, for example, you're going to see all the versions. Well, it's so long, so let's try something new, like Tesla. Let's say that. We go Tesla. Wait. Here, what's Tesla? Yeah, Tesla.com. So over here, we're going to see all the versions of Tesla from 2025 all the way back to, let's say we want to see its version on 2016. We have a lot of versions here, and We can take a look at this one, click this one. It's going to take us to that specific version on that day to see. All right, so this is what the website looks like on December 14, 2026. So what is important? Because even though these are old versions of the websites, there may still be some files or directories hidden in a server that are not deleted. And by visiting and doing some enumerations on this one, we are able to retrieve those important files. Also, we also learn about, maybe there was some leaked credentials or some password text presented online that wasn't deleted by the server too either. So it's helpful to take a look at this. Now, if you don't like the website version, you want to be, then you can use the tool developed by Tom Nam Nam. Basically, it does the same thing. This is the repository here. You clone it, you go into that and install all the dependencies. You build it, and then once you run against a website like Wayback URL, let's try that. So cd Wayback URL. What else do we do? Sudo install Golang and go build. Based on the screenshot right here, it's going, once we run this tool against a website, it's going to provide us all the necessary or all the files that I think is valuable to us as a pen tester or as a attacker, depending on where you are. So GPC JSON, node information, security.txt. This is interesting. Trust.txt, also interesting. AI plugins are okay. Google Docs, another example. Now, up to this point, you might have been familiar with Google Docs. If not, then I would recommend you, take a look at it. Try to get familiar with that because it's very useful. To find administrative panels, here you specify the site. In this case, I'll try TryHackMe's.com, and then in URL, you look for the admin, for example. Let's try the Google Docs site. And then in URL, let's see if my profile pops up. It doesn't pop up. What is my TryHackMe's profile? Let's see what URL. In this trace one, doesn't show anything. So sometimes it works, sometimes it's not. So you're gonna have to play with it, try to figure out whatever it is. Anything else not available on the website. Another thing you can try is like 5-type, which is the log or PDF file or text file or robot.txt or whatever it is that contains the string password here on the site that we want to look for. I'm not going to be doing a demo on TryHackMe. I don't want to get any trouble, but this is the concept that we're supposed to do. Or like in the title, this is the title TryHackMe browser based. This is TryHackMe enumeration. Brute force. This is the title. Okay. So yeah, speaking of OSINT, these are the two main techniques that are widely used by attackers and red teamers. It's very powerful. Depending on the goal, on the ultimate goal, you may focus on one tool over another. All right, so that's it for. Oh wait, hold on. Were we waiting for? No, we were waiting for anything. Oh, we were waiting for the Wayback URL. Okay, so we run this one. Oh, we have to build it first. Yes, and now we can run it. Wayback URLs and then TryHackMe. I accidentally closed the browser. Take a look at what it is. Okay, nothing to see. Cool. So yeah, here we are provided with a long list of URLs and directories. It's going to be very intimidating going through the list, but if you know what you're looking for, this is going to be very, very helpful. All right, so that's it for on the room today. I hope you like it and enjoyed all the exercise in the room. If you have any questions, feel free to reach out to me. And thank you again for watching my video. I'll see you next time. Bye.